Hello and welcome to the section 5 of unit 3 video on completing the square. So in the last section we talked about taking the square root of each side and being able to use that to solve for x in a quadratic equation. And this is a bit of an extension to that because we were only given two specific situations where we could use that, and that is if we had x either no linear term, so we had just an x squared term, or if we had it in vertex form where we had x within a square and there were no other x's around. Well, you may recall that we had a type of trinomial that can be written that way, and that was a perfect square trinomial where we have an x term within a square and we're able to have that x be the only x around. So let's talk about what we did in the last section a little bit here and just kind of refresh you with an example here. Say you have x minus 2 quantity squared equals 80. Well, to solve this, all we had to do was take the square root of each side, and then after we take the square root of each side, we're left with x minus 2 on this side. We can break down 80 into 16 times 5, 16 being our perfect square, and then we just add 2 to each side and we go ahead and simplify this at the same time. So we ended up with an answer 2 plus or minus 4 times the square root of 5. Okay, so very easy to solve for that. Well, you may recall that the quantity x minus 2 quantity squared, that is a perfect square trinomial. If you were to expand it, it would look like a squared plus 2ab plus b squared. Okay, so if we were to expand x minus 2 quantity squared, it would expand to x squared minus 4x plus 4, that being a perfect square. Okay, we can tell that something in standard form is a perfect square if we take the first term, so down here, if we take this first term, take the square root of it, and you have x. Take the square root of the last term, that's 2. So you have 2x. Take 2x and multiply it by 2, you get 4x, which is our middle term. Okay? And then that sign in the middle, that second term sign, just tells you what sign you're going to use within your factoring. Okay? And you'll notice that it's positive here on that first one, it's negative here on the second one. So, from this, we find that when we are given a perfect square trinomial, then we can factor and solve by taking square roots, which is what we learned in the last section. Okay? So, let's do a few examples involving this. So, in this first example, we recognize this is a perfect square trinomial because we have x times 5, which is 5x, double it, you get 10x, which is our middle term. So, we can factor this down into x minus 5 quantity squared equals 9. The reason we can factor this down is because it's a perfect square trinomial. The reason why we have the minus is you have the minus here. So you take the square root of the first term, square root of the last term, take the sign in the middle, put it in between. Now from here, we're just going back to what we did in the last section. So this first step's really the only thing new that we're doing here. Because from here, all we have to do is take the square root of each side. And when we do, we get x minus 5 equals plus or minus 3. X equals 5 plus or minus 3. And we can actually get two answers from this because these are both just numbers. So x equals 8 or x equals 2. So those are our two solutions. If we go over to b here, x squared is a perfect squared, 36 is a perfect squared, When you square the square roots of those two terms, you get 12x, okay? Because you have x here, you have 6 here, 6x times 2 is 12x. So it is a perfect square, so we take the square root of the first, square root of the last. Our middle term is positive, and that's how you factor it. So now we will take the square root of each side, plus or minus the square root of 48 on the right-hand side. We can break down the square root of 48. That breaks down into the square root of 16 times 3. 16 being our perfect square. Let's go ahead and subtract 6 from each side. Square root of 16 is 4, and you have the square root of 3. And so there's our answer for this one. All right, let's move on to a couple more examples here. X squared is a perfect squared. 16 is a perfect squared. 4x times 2 is 8x. So this is indeed a perfect square trinomial. You always want to check that first to make sure. So the square root of the first term is x. Square root of the last term is 4. The middle term is negative, so we stick a minus sign in. And now we're just taking the square root of each side to solve. X minus 4 quantity squared equals plus or minus the square root of negative 81. So we have x minus 4 equals plus or minus 9i. So x equals 4 plus or minus 9i. And then in this last example, we have x squared is a perfect squared. 64 is a perfect squared. 8x times 2 is 16x. So we take the square root of the first, square root of the last. The middle term is positive. And now we're ready to take the square root of each side. So we end up with x plus 8 on the left-hand side. On the right-hand side, we can do a little bit of simplifying of that square root. 45 is 9 times 5, so 9 is our perfect square that we can pull out. We're going to pull out the square root of negative 1 while we're at it. So x equals negative 8 plus or minus 3i square root of 5. Okay, let's move on to the next part of this. So you can see it's pretty easy to implement when you're given a perfect square already. Unfortunately, not all trinomials are perfect squares. We can, however, mathematically rewrite an equation to create a perfect square trinomial so we can solve using square roots. This process is called completing the square. So this is how it works. We're going to get our quadratic equation in the form x squared plus bx equals c. So basically everything that doesn't have an x gets put to the right-hand side. Everything with an x stays on the left. Then we're going to complete the square. Once we complete the square, then we'll be able to take the square roots. So this is basically what we're going to do. These are the steps. It's easier once you see it, but we're going to write the equation in that form as I just mentioned. Then we're going to find what b over 2 squared is. So basically you're going to take that number in front of the x, divide it by 2, and square it. And then you're going to take that number and add it to both sides. And then from there we'll factor, take the square root, and solve. Okay, so these procedures are here for you. They make more sense once you see it. So let's do some examples with it. So these procedures work when your leading coefficient is 1. Okay, I should mention that. So you'll notice that we don't have a number in front of any of these x squared terms on these examples, okay? But you'll also notice these are not perfect squares because, first of all, 27 is not a perfect square, so right there alone is not a perfect square trinomial. But we can make a perfect square trinomial. So first thing we're going to do is get that negative 27 over to the other side by adding it. So we got x squared minus 12x equals, when we add 27 to negative 4, we get 23. Okay, on the left-hand side, we're going to complete the square. We're going to take 12, divide it by 2, which gives us 6. When you square 6, that's 36. So we're going to add 36 to both sides. Because you can't just add it to the left-hand side. You also have to add it to the right-hand side, because whatever you do to one side of the equation, you have to do to the other to keep it equal. Now we have a perfect square trinomial on the left-hand side because we created it. So we take the square root of the first, we take the square root of the last, our middle term is negative, and then we're going to go ahead and add these two numbers, which gives us 59. So now we're back to what we did in the last section. We're going to take the square root of each side. Square root of this side is x minus 6. We can't simplify the square root of 59, so that just stays as it is. So all we've got left to do is add 6 to each side. So you've got x equals 6 plus or minus the square root of 59. All right, let's move on to the next example. Again, we have got to get our x terms on one side. So we're going to have to add 29 to each side. And when we do, we get 26 on the right-hand side. Now we're going to complete the square. 4 divided by 2 is 2. 2 squared is 4. So we're going to add 4 to each side. So here we have a perfect square trinomial now. So square root of the first, square root of the last, middle term is positive. 26 plus 4 gives us 30. So we take the square root of both sides. We can't simplify the square root of 30, so that just stays as it is. And we subtract 2 from each side. So our answer is negative 2 plus or minus the square root of 30. All right, moving on to these last two examples. We have x squared plus 8x plus 76 equals negative 3. This is not a perfect square trinomial, so we are going to move everything over. Or not everything, we'll move the 76 over, keep the x's on the left-hand side. So when we do that, we're going to end up with negative 79 on the right-hand side. Now we're going to complete the square on the left. So 8 divided by 2 is 4. 4 squared is 16. So you're going to put 16 here. We're going to add 16 to the other side as well. And so now we can factor the left-hand side as a perfect square trinomial. The square root of the first, square root of the last, sine of the middle, just like that. And then we've got negative 63. Then we're going to take the square root of both sides. So we got plus or minus square root of negative 63. So that will simplify down. So we've got x plus 4 on the left-hand side. On this side, we can break up 63 as 9 times 7, and then multiply it by our square root of negative 1. And then we get our whole answer pulled together. Negative 4 plus or minus 3i square root of 7. And then in this example, we're going to move 60 to the other side by subtracting it. So we have negative 57. And then we complete the square. So 10 divided by 2 is 5. 5 squared is 25. So we have to add 25 to both sides. So on the left-hand side, we can factor this: square root of the first, square root of the last, sine of the middle term. And then the right-hand side is going to be negative 32. So now we're going to take the square root of both sides, plus or minus the square root of negative 32. So we have x minus 5 on the left-hand side. We can break up 32 into 16 times 2. We've seen that one plenty of times, so you should be getting pretty familiar with some numbers that can be broken up with a perfect square at this point. Add 5 to each side. Square root of 16 is 4. Square root of negative 1 is I, and then you got the square root of 2. So you've got x equals 5 plus or minus 4i square root of 2. Okay, let's go on to the last topic in this section. So we just did a few examples where our leading coefficient was 1. But what happens if our leading coefficient is not 1? What if we have a number in front of our x squared? Well, it really is just one more step that you're going to have to take. So just like we did before, collect the variables on one side, constants on the other. That first step is going to be the same. But what's going to change is, after you do that, you're going to have to divide everything by that constant or that coefficient in front of your x squared term. So divide both sides by a to make that x squared term have a leading coefficient of 1. And then from there, you're going to do everything we just did. You're going to divide b by 2, square it, add that to both sides, and then go from there. So let's do a few examples of that. So here we have 2x squared minus 16x minus 76 equals 0. So first thing we're going to do, move our 76 to the other side. So you got 2x squared minus 16x equals 76. Then we are going to divide everything by 2. So the first thing divided by 2 is just x squared. 2x squared divided by 2 is x squared. Negative 16x divided by 2 is negative 8x. And 76 divided by 2 gives you 38. And now we're going to complete the square like we did in those previous examples. So 8 divided by 2 is 4. 4 squared is 16. So we will add 16 to both sides. We can factor the left-hand side. Square root of the first is x. Square root of the last is 4. The sign of the middle term is negative. And then on the right-hand side, we have 54. Take the square root of both sides, which goes back to the last section that we did. So you notice everything we've done here is just been adding one more step. Each step of the way, we've been adding one more thing to do. Square root of 54 can be broken down into the square root of 9 times 6, 9 being our perfect square. And so we have 4 plus or minus 3 square root of 6. All right, for the next one, we're going to subtract 28 from each side. That's our first step. Get our x's on one side. Get our constants on the other. Then we're going to divide everything by 3. So the first term would be x squared. The next term would be 6x. And oh my, we've got a fraction, but that's okay. We know how to deal with fractions. Let's go ahead and complete the square on the left-hand side. 6 divided by 2 is 3. 3 squared is 9. So we're going to be adding 9 to each side. When I add 9 to this side, I'm going to add it as 27 over 3. Because 27 over 3 is just 9. I just wanted to go ahead and get my common denominator while I was at it. Okay. So the left-hand side, we can go ahead and factor. So we're going to have x, the square root of the first term, square root of the last term, sine of the middle term, and we're factored. On the right-hand side, because we have a common denominator, that very easily becomes negative 1/3. So now we're going to take the square root of both sides. And when we do, we end up with x plus 3 on the left-hand side. On the right-hand side, we're going to rationalize that. So we're going to multiply the top and the bottom by the square root of 3. So we get the square root of 3 over 3. And then I'm going to pull out my square root of negative 1. And all that's left is to pull it all together. Subtract 3 from each side. We've got plus or minus. Square root of negative 1 gives you I. And then we got the square root of 3 over 3. Okay, let's go on to the next two examples. So for C, we are going to go ahead and get that 60 over to the other side. So you got 4x squared minus 8x equals, when you subtract 60 from 8, you get negative 52. Now we're going to divide everything by 4. So that gives us x squared minus 2x equals negative 13. We'll complete the square on the left-hand side. So 2 divided by 1, or 2 divided by 2, I should say, is 1. 1 squared is 1. So we're going to add 1 to each side. We can factor the left-hand side. We've got x plus x is the square root of x squared. Square root of 1 is 1. Sign of the middle term is negative. And then we have negative 12 on the right-hand side. Take the square root of each side. Make sure that looks like a parentheses. Plus or minus the square root of negative 12. We've got x minus 1 on this side. We've got plus or minus. We can break down 12 into 4 and 3. And then we've got our square root of negative 1 out there. And we pull it all together and have our final answer, which is 1 plus or minus 2i square root of 3. And then in our last example here, we have 5x squared minus 20x. Add 15 to each side. That gives us 25 on the right. Then we're going to divide everything by 5. So that gives us x squared minus 4x equals 5. We're going to complete the square. So we got x squared minus 4x. 4 divided by 2 is 2. 2 times 2 squared is 4. And we've got to add 4 to this side as well. We can factor the left-hand side. Square root of the first, square root of the last, sine of the middle term equals 9. And now we're going to take the square root of each side. So you got x minus 2 quantity squared plus or minus the square root of 9. So you have x minus 2 equals plus or minus 3. So x equals 2 plus or minus 3. And we can break that into our two answers because those are just numbers. 2 plus 3 is 5. 2 minus 3 is negative 1. And those are our solutions. So we have looked at completing the square in two senses here. Once when we have a is equal to 1 and when a is greater than 1. And the only difference is if a is greater than 1, we're going to divide everything by a first, and then we'll just proceed as normal. All right, the next section is going to get us into the quadratic formula. We will be talking about the quadratic formula and how that works, and we will move on from there.